Hey fellas, welcome back to the channel and I hope that you all are doing well. In today's video, we are diving into the fascinating world of computer and programming. So let's begin our video. In this video, we will cover input and output devices, how we communicate with computers, CPU and storage devices, the brain, and the memory of the computer. Flowcharts, the ultimate map for solving problems, and at last, introduction to C++, the superhero of programming language. And I am hoping by the end of this video, you will have a solid understanding of these concepts and maybe even a few fun facts to impress your friends. So let's get started. So first we have input devices. So, what are input devices? These are tools that allow us to send data or commands to a computer. Without input devices, we wouldn't be able to interact with computers at all. Here are some common input devices. Keyboard lets you type text, numbers, and commands. The fun fact is that the QWERTY layout was designed in the 1870s to prevent typewriter key for jamming. The mouse controls the cursor of the screen. The first computer mouse was made of wood and had only one button. The microphone captured audio input like your voice or voice command or video call. The webcam is also a useful input device. It captures video input for communication or recording. Touchscreen is a new input device that let you interact directly with the screen using touch. Did you know that the first touchscreen was invented in the 1960s? So now we will take a daily life example. If you are watching this on a smartphone, try using your touchscreen to pause this video. See, that's an input device in action. Input devices are like the sense of a computer. They help it understand what we want it to do. Next, let's talk about how computers respond to us using output devices. So now that we have sent data to the computer using input devices, let's see how the computer respond with output devices. These devices take proceed data and present it in a way we can understand. Here are some common output devices. Monitor display usually output like text, images, and videos. And the fun fact is that the first computer monitor, the CRT, was a bulky and heavy compared to today's sleek displays. Printer produce hard copies of digital documents. The first computer printer was IBM 4003 that was so loud that it needed a soundproof enclosures. The speaker produced audio output like music or speech. Sorry. The first computer speaker was introduced in 1981 by IBM. The next we have the projector. Displays visual output on a large screen, perfect for presentation or movie nights. So now we will see a practical example of this. If you are watching this video with speaker or headphone, you are using an output device right now. Try adjusting the volume to see how the output changes. Output devices are like the computer's way to talk back to us. So now let's dive into the brain of the computer, the CPU. The CPU, central processing unit, is the brain of the computer. It performs all the calculations and make decisions. Without the CPU, your computer wouldn't be able to do anything. Here's how a CPU works. So the CPU fetch the information from the memory. It decodes the instruction to understand what needs to be done. Then execute it, perform the required calculation or action. Then it store the results back in the memory. Fun fact is that the modern CPUs can perform billion of calculation per second. For example, in Intel Core i7 processor can handle up to 4.7 billion instructions per second. Amazing, isn't it? Type of CPUs. There are two types of CPUs, single core and multi-core. Older CPUs with one processing unit are single core, and modern CPUs with multi-cores are known as multi-core, dual core or quad core for faster performance. So the interactive example of the real life is that if you are watching this video, your CPU is working hard to decode and display the content. Try opening another app or program. Your SIG will handle both tasks simultaneously. So now that we have covered the brain of the computer, let's start talking about the storage devices. Storage devices are where your computer keeps all its data, even when it is turned off. There are two main types of storage, primary storage and the secondary storage. The primary storage stores data temporarily. RAM is one of it. RAM stands for Random Access Memory. Temporary storage for running program. When you open an app, it loads into RAM for quick access. Cache memory is even faster than RAM. It stores frequently used data for quick retrieval. The secondary storage, also known as permanent storage devices, it include HDD or hard disk drive. It use spinning disk to store data. It is slower but has large capacities. SSD, also known as solid state drive, use flash memory for fast access. It's more expensive but much faster than HDDs. USB flash drive is also example of secondary storage device. It is a portable storage for transferring files. Cloud storage. It stores data on remote server accessible via the internet. The fun fact is that the first hard disk, the IBM 350, was introduced in 1956 and could store only 5 MBs of data, less than the single MP3 song. So now check how much storage your device has on a smartphone. Go to the settings, storage on a computer, check this PC or my computer how much space is left. Now that we have covered the brain and the memory of the computer, let's start talking about how we can plan what we want the computer to do using flowcharts. So, the flowchart is a visual representation of a process or algorithm. It uses symbols and arrows to show the steps involved in solving a problem. For completing a task, think of it as a roadmap of your program. It helps you plan, organize, and visualize the logic writing many code. Flowcharts are not just for programmer, they are used in many fields like businesses, engineering, and even everyday life. For example, company uses flowchart to map out workflows and engineers use them to design systems. So why are flowcharts important? They help you break down complex problems into smaller and manageable steps. They make it easier to communicate ideas with others. They also help us identify error in your logic before writing code. Now let's take a closer look at the symbols used in flowcharts. Flowchart are specific symbols to represent different type of actions or steps. Here are the most common ones. Oval represent the start or end of a process. Every flowchart begins and ends with this symbol. The rectangle represent a process or action. For example, add two numbers or calculate the total. The diamond represent a decision point. This is where you ask a question like, if the number greater than 10, the number determines the next step. The arrow shows the flow of the process. It connects the symbols and indicates the order of a step. Parallelogram represent input or output. For example, enter a number or display the result. So a pro tip in this is that always use the correct symbols to make your flowchart clear and easy to understand. Now let's talk about best practice for creating flowchart. Create a good flowchart requires more than just drawing symbols. Here are some best practices to keep in mind. Keep it simple, avoid unnecessary complexity. Use clear and concise labels for each step. For consistent symbols, stick to standard symbol to avoid confusion. Follow a logical flow, ensure the steps in the correct order, use arrow to guide the reader. Test your flowchart, walk through the flowchart step by step to make sure it works as intended. Common mistakes that are made in the flowchart are that overloading the flowchart with too many details, using non-standard symbols that others might not understand, forgetting to include decision points which can lead to incomplete logic. Now that you know how to create flowchart, let's explore some real-world application. Flowcharts are used in many industries to solve problems and improve process. Here are some examples. Software development. Programmers use flowchart to design algorithms and plan their code. Business companies use flowchart to map out workflow like customer service process or manufacturing steps. In education, teachers use flowchart to explain complex concepts like the scientific method or decision-making process. Healthcare doctors use flowchart to diagnose patient or plan treatments. Fun fact is that NASA uses flowchart to design mission plan for space exploration. For example, the Mars rover mission were planned using dedicated flowcharts to ensure that every step was executed perfectly. Flowcharts are a universal tool that can be applied to almost any field. Let's connect this to programming by introducing C++. Flowcharts are especially useful in programming because they help you plan your code before writing it. For example, if you are writing a C++ program to calculate the average of three numbers, you can use a flowchart to map out the steps. Start, input three numbers. Start, input three numbers, calculate the average, display the result, and end. By creating a flowchart, first you can ensure your program's logic is sound and avoid errors later. Now let's dive into C++ programming and see how it all comes together. The flowchart in C++ is just like the treasure map. The next section is Introduction to C++. Now that we have planned our program using a flowchart, let's dive into C++. It is one of the most powerful and versatile programming language in the world. C++ is used for everything from system software to game development, and it is a must-learn language for anyone serious about programming. But before we get into the technical detail, let's begin a quick look at the history of C++. Did you know that C++ was created by Bertrand Stroustrup in the 1980s? It started as an extension of the C language, which is why it was originally called C with classes. The name C++ comes from the increment of brackets plus plus, which mean one better than C. C++ is known for its speed, efficiency, and flexibility, make it a favorite among developers. Now let's explore some of its key features. C++ is packed with features that make it powerful and versatile language. Here are some of the most important ones. Object-oriented programming or OOP. C++ supports OOP, which allow you to organize your code into objects and classes. This make your code more modular, reasonable, and easier to maintain. For example, if you are building a game, you can create a player with class class with attributes like health and score, and methods like move and attack, speed and efficiency. C++ is a compiled language, which means it is directly converted into machine code. This makes it incredible fast and efficient, perfect for performing critical applications like games and operating systems. Rich standard libraries. C++ come with a standard template library STL that provide pre-built functions and data structure. This saves you time and effort when writing code. Platform independence. C++ code can run on different platforms, Windows, MacOS, Linux, with minimal changes. This make it a great choice for cross-platform development. Low-level manipulation. C++ allow you to work closely with hardware and memory, give you fine-grained control over your program. Fun fact is that C++ is so fast that it is used in the financial industry for high-frequency trading, where millisecond can make a huge difference. Basic syntax of the C++. Now let's take a look at the basic syntax of C++. Don't worry, if you are new to programming, I will break it down step by step for you. Here is a simple C++ code that prints hello world to the screen. Let's break it down. Hashtag include IOStream. This line includes the input output library which allow us to use cout for printing text. Using namespace std, this line tells the compiler to use the standard name place, so we do not have to type std before every command. In int main, this is the main function where the program starts executing. Every C++ program must have a main function. Cout, this line prints the text hello world to the screen. Return 0, this line ends the program and returns a value of 0, which means success. So the pro tip is this: always end your statement with a semicolon in C++. It like a period at the end of a sentence. It tells the compiler that the statement is complete. Now that you have seen a simple program, let's talk about some real-world application of C++. C++ is used in a wide range of industries and applications. Here are some examples. Game development. C++ is the backbone of many game engines like Unreal Engine and Unity. Games like Fortnite and Call of Duty are built using C++. Operating system. Major operating systems like Windows, Linux, and macOS have part written in C++. Web browsers. Browsers like Google Chrome and Mozilla Firefox use C++ for their rendering engine. Embedded system. C++ is used in devices like smartwatches, cars, and IoT devices because of its efficiency and low-level control. Finance. C++ is used in high-frequency trading system where speed is critical. Fun fact is that the Mars rover used software written in C++ to navigate and perform scientific experiment on Mars. So, how and why should we learn C++? So, why should you learn C++? Here are some reasons. High demand. C++ developers are high in demand, especially in industry like gaming, finance, and software development. Foundation of other languages. Learning C++ make it easier to learn other languages like Java, C hashtag, and Python. Performance. If you need speed and efficiency, C++ is the way to go. Versatility. C++ can be used for everything from small programs to large-scale systems. Fun fact is that many of the world top-notch companies like Google, Microsoft, and Amazon use C++ in their product and services. Now that you know why C++ is so powerful, let's wrap up with a quick recap. Recap and call to action. Let's recap what we have learned about C++. It is a powerful, versatile, and efficient programming language. It is used in game development, operating system, web browsers, and many more. Learning C++ opens up exciting career opportunities and help you understand how computer works at a deeper level. If you are ready to start your C++ journey, there are many resources available online, including tutorials, courses, and coding challenge. If you enjoyed this video, consider it like, subscribe, and sharing for more programming content. Alright, let's take a moment to recap what we have learned in this video. We have covered a lot of ground, so here is a quick summary. Input and output devices. We explored how input devices like keyboard, mic, and microphone allow us to communicate with computers, and how output devices like monitors, printers, and speaker give us the result of the communication. CPU and storage devices. We dive into the brain of the computer, the CPU, and learn how it processed data using the fetch, decode, execute cycle. We also talk about storage devices from fast SSDs to portable USB drives and how they store data permanently. In flowcharts, we discuss how flowcharts are like trail maps for solving problems. They help us visualize us and plan our program before writing any code, make the development process smoother and more efficient. Introduction to C++. Finally, we explored C++, one of the most powerful programming language in the world. We looked at its history, key feature, basic syntax, and real world application from game development to operating system. Understanding this concept is essential because they form the foundation of how computer works and how we interact with them. Whether you are a beginner or an experienced programmer, knowing what input output devices, CPU storage flowcharts, and C++ will help you build better programs and solve problems more effectively. Plus, learning C++ opens up a world of opportunity in industries like gaming, finance, and software development. It is a skill that is in high demand and can take your career to the next level. If you enjoyed this video and found it helpful, don't forget to like the video to let me know. Share it with your friends who might be interested in learning about computers and programming. Subscribe to the channel for more content like this. I will be covering more programming topics, tips and tricks in future videos, so stay tuned. Thanks thanks so much. Thank you so much for watching. I hope this video gave you a clear understanding of how computer works, the importance of flowchart, and why C++ is such a powerful programming language. Remember, every expert was once a beginner. So keep practicing, keep learning, and most importantly, have fun with it. Until next time, happy coding, and I will see you in the next video. Bye.